So this is the steps for finding an angle between two planes. First thing you want to do is go ahead and mark the planes that you're given in the problem. In this case, it's the bar 1, 2, and the 1 bar 3, 3. You might want to go ahead and also label them. It's going to make things easier, or to keep track. It's just good practice, just so you can realign them later in different steps. This is the easiest or simplest of all the stereograph projection operations, but it's still a good fundamental to know. You're going to transfer your transparent sheet onto a wolf net, and then you want to align the two planes so that they end up on the same great circle. And those great circles are the vertically running circles. So just, again, double check, make sure your planes are approximately on the same great circle. They don't have to be exact, but make them as exact as possible. So once you've aligned the planes on that great circle, you want to go ahead and grab your marker and start counting the angles in between those two planes. Keep in mind, each little tiny box is a 2 by 2 degree box. So when you're counting 5 degrees or 5 boxes is actually 10 degrees. So keep that in mind. Make sure you're not actually counting half of what you're supposed to be. So you can go ahead and also pick up your projections and your wolf nets and do this along so that it's more practice. These are just planes I just picked randomly, and the two planes you'd be given in the problem. So again, you just count the angles in between them, and in this case, it is a 56-degree angle in between those two planes. So this is the steps for finding the zone axis of two planes. This is a good fundamental, again, to understand for when we start doing reciprocal lattices or anything along those lines. So the first thing, again, you want to go ahead and mark the planes that you're given in the problem and label them. In this case, again, it's the same planes from last time, the 2 bar 1, 2, and the 1 bar 3, 3. After you label them, you want to go ahead and move the transparent sheet onto the wolf net, and this time you want to move one of the planes onto the equator. Doesn't matter which plane. In this case, I chose the 2 bar 1, 2. I move that plane to the equator, making sure my center is still the same. And I could have done this with the 1 bar 3, 1. It would have given me the same thing because I'm eventually going to end up doing this for each pole or each plane. From then, you want to count 90 degrees from the plane that you move to the equator. Once you've counted 90 degrees, you want to go ahead and mark the great circle that corresponds to that 90 degrees. This is essentially a line of all of the planes that are 90 degrees away from that 2 bar 1, 2 plane that you marked. After we do this, we're going to go ahead and move the other plane onto the equator. Again, making sure we keep the center the same. I don't have a pin, so I had to actually make sure my center was the same, but if you have a pin, it's a little bit easier. So again, you move it to the equator. It doesn't matter which side of the equator, as long as you maintain the same side for both planes. And again, you count 90 degrees away from that plane to make sure you land on the right great circle. You're going to notice after you mark these two great circles, you have an intersection of the two great circles, and that's not a coincidence. That essentially says you found a singular plane that intersects those two great circles, and that plane is going to be the zone axis of those two planes that you were given. That plane is 90 degrees away from both of those, from both of the 2 bar 1, 2 and the 1 bar 3, 3. So then after, you go ahead and put your transparent sheet back on the wolf net and realign the original planes. In this case, it just happened to be realigned. You just want to realign them, and then the plane that intersects, you go ahead and mark it, and that's going to be your zone axis. Okay, so this is finding the planes of a given zone axis, in this case the 2, -3, 1. First step, you want to go ahead and mark that given zone axis, the 2, bar 3, 1. Move your transparent sheet back to the wolf net, same step as the other time. Again, you're going to rotate so that that plane that you marked ends up on the equator. Once you do that, you start counting 90 degrees away. This is essentially the reverse of the previous step. You're essentially given a zone axis, and from that zone axis, you're supposed to find all the planes that could be a part of that zone axis. Essentially, all of the planes that are parallel to that zone. Once you found that 90 degrees away great circle, you want to go ahead again and mark it. And once you've marked it, you want to make sure it's a thin line, but really it's not that big of a deal. This isn't exactly the most accurate way to do anything, but just make sure it's pretty accurate. After that, you want to go ahead and put it back on your stereograph projection and realign the 2, bar 3, 1 with its original plane on the page. Nope. There it is. Okay. So that's the 2, bar 3, 1. And if you notice, the great circle intersects all of these planes, and all of these planes are now part of that zone axis. This is an important step when you're drawing a reciprocal lattice, because you're going to have to find planes of a zone in order to find the reciprocal lattice and be able to draw it. Alright, so this is the steps for rotating a plane about a pole. You want to go ahead and mark the plane, which in this case is the 101, and the pole, which in this case is the 011. And you're going to rotate it for 110 degrees clockwise. All three of these are going to be given in the problem. Once you've marked them, you want to go ahead and move the transparent sheet onto the wolf net. And it's important that you move the pole to the equator. In this case, the pole is actually on the equator, so you don't have to worry about rotating it. But if it weren't, you would want to move the pole, which in this case is the 011, you would want to move that to the equator. Once you've moved it to the equator, you want to count the number of degrees it would take to bring it to the center of the wolf net, which is where that small black marking is. It's going to, in this case, take about 46 degrees to move the 011 to the center of the wolf net. So you want to go ahead and mark your new 011 and cross out the old one. You want to also go ahead and rotate your plane, which is the 101, the same amount of degrees, 46 degrees. So that plane is now over here, and I'm crossing out the old one. Great. Now I want to go ahead and rotate 110 degrees clockwise. In order to do this easily and be able to track yourself, you want to go ahead and mark a point on the outside of the circle, usually on the equator where the 0 is, and you want to rotate 110 degrees clockwise. Alright, so right now I'm going to hit 90 right there, and then 120 is going to be right there. That's going to be a 120 degree rotation. Great. Now our planes are in a new position. We're going to want to go ahead and reverse what we did. So we're going to count backwards 46 degrees for both of those planes. So right now I'm counting the 101, 46 degrees backwards. That's my now, again, new 101. I'm going to cross out the old one and label the new one. I'm going to do the same thing with the 011. I'm going to count 46 degrees. I wrote it backwards in this case, and there's no bar. I don't know why I wrote a bar. I think I just looked at the other one. Yeah, there's no bar. This is the 011, not the 1 bar 1 0. So again, I marked the new one, and I crossed out the old one to make sure I don't get myself confused. Now you have a lot on your transparent sheet, but don't worry. You've crossed out all the ones you don't need, so just worry about the ones that you have marked. Then you want to go ahead and realign the pole with its original position. Notice how I'm putting the 011 back where it was. There's a little bit of error, so I'm realigning the page to make it more true to what it actually is supposed to be. And when you realign the 011 with its original plane, you end up seeing that the 101 crosses at a new plane, not the 101, but in this case, the bar 101. And that's going to be the plane that the 101, after being rotated, is going to be equal to.